Alright, so I'm just going to do this one again. You have the kinetic energy formula, which is 1 dk equals half mv squared. So I substitute in the half and write in mass as m, and the velocity squared as 5.5 recurring. I'm going to keep about 4 decimal places, even though I'm going to end up keeping about 2 at the end. Alright, so what I'm going to do is I'm going to type in 5.5 recurring squared, which is on my calculator. 5 squared, and then I times by half, which is 0.5. Okay, so that's going to be 15.43 m, but I'll keep more decimal places than I need. 4320.2067 m. And then I divide by 15.432067. So my mass is going to be divided by that, so that's going to be here. And we multiply by 1. Oh, let's not do that. Undo. Divided by 1, 3, 4. I'm doing really well this morning. 1, 3, 4, 5. Okay, so that's 87.156, which rounds back to 87.6. I think that might be easier to follow than what I did before. Showing you how to do gravitational potential energy now. So you have Ug equals mgh, where Ug is the symbol for gravitational potential energy, and the units are in joules. That's a J. You also have mass in kilograms, like before, and you have g, which is the gravitational acceleration on the Earth, and then you have h, which is the height above ground. So here's my picture of the ground, and we've got height over here, and the mass of the objects somewhere over here. Not doing very well today. Let's see if this continues. Great, not working. I don't know. Thanks, buddy. No, I don't want to do that. Okay, we have slight slow issues. Never mind, let's continue. Alright, so what we have here is a question where you have the mass given to you, you have a height of 1.5 meters given to you, and you're asked to find the student's gravitational potential energy. So what I have is to write down what the question is asking you to find, which is the gravitational potential energy. And the diagram here is that you have a height of 1.5 meters, and you're asked to find the gravitational potential energy, and the mass is 64 kilos. So you probably should write the mass in. 64 kilos. Okay. Now this is what I call a plug-and-play question, because all that you know is on the right-hand side. We know the mass, we know the height, we know g. So you can actually substitute them straight into the formula. So Ug is 64 times 9.8 times 1.5, and when you type in your calculator, you get 940.8 joules. And if you answer the question correctly, it is 940 to 2 significant figures if you want to be accurate. But at year 10 level, I'm happy with having this answer, the 940.8, because it's correct to 2 decimal places. Alright, now here, just confirm that I have audio. Alright, I guess tough luck if I don't have audio. So then here we've got a height, which is 173 centimeters. So I put a little star to remind me that you need to change it to meters. Then we've got a ball with a gravitational potential energy of 14 joules. So I've got a circle with UG around it, and mass, which is m. So the question is asking you to find the mass, which is m. So my diagram is that it's 173 centimeters above the ground, and the mass is the unknown, and we've got a gravitational potential energy of 14 joules. So because it's in centimeters, the height, I need to change it to meters first. So you should know that 1 meter is 100 centimeters. So that means to go from centimeters to meters, you have to divide by 100. So you get 1.73 meters. So if we scroll down now, you'll just plug it into look at your formula sheet, and a formula sheet says that UG is mgh. So we know UG is 14, sorry. We have a mass that's unknown, so we leave it as m. We know G is 9.8 and H is 1.73. So if we work out the right-hand side numbers, 9.8 times 1.73, you get 16.954 meters. Equals, 6.954 times m equals 14. So to get rid of the 16.954, I have to divide both sides by the same number, 16.954, which means that you'll get a mass of 0.82576 kilograms. So if we round that to 2 decimal places, we get 0.83 kilograms. Now that was called the substitute and solve method. If you prefer to have just one step calculations, this is called the solve then substitute method. So we start with the original equation, UG equals mgh. And I think I'll just see if I can write these out to get this going. We start with the original equation, UG equals mgh. And we want to get m to be the subject. So we're going to divide by gh, both sides. There is a bit of a lag, but hopefully it will catch up. Perfect. So then if you divide by gh, that gets rid of the gh on the mass side, and I end up with ug divided by gh on the other side. Then we know that our ug, or potential energy, is 14. So it's 14 divided by 9.8 times 1.73, which is a nice one-step calculation in your calculator. And it is a bit laggy, so it will catch up with me later. Come on, Cal. You can do it. Feel free to fast forward this part of the video. Here we go. There's our catch up. Alright, cool. So now this next one has a roller coaster sitting with a GPE of 1323 kilojoules. So you need to make that into joules. And it's got a mass of 4.5 tons, which is also something you need to convert to kilograms. It's asking you to work out the height, which is h. So I put in there that the question is asking you to find h, which is height. My diagram here is a roller coaster. The mass is 4.5 tons and the GPE is 1323 kilojoules. So over here I've got the calculations to convert to from kilojoules to joules. And if you remember, 1 kilo something is 1,000 of the something. So in this case the something is joules. So 1 kilojoule is 1,000 joules, which means if I want to go from kilojoules to joules, I have to multiply by 1,000 first. So then you'll get 1,323 times 1,000, giving you 1,323,000. With your 4.5 tons, you've got to remember that 1 ton is 1,000 kilograms, and then you'll have 4.5 tons equaling 4.5 times 1,000 kilograms. So down below I've got your two methods side by side again, and I've substituted in the gravitational potential energy and the mass and the G, 9.8. That has given me 44,100, and to get rid of that 44,100, I divided by both sides by 44,100, which gives you 30 meters. If you're doing it the substitute and solve method, that was the left-hand side. The right-hand side is the other way to do it, if you want to solve first and then substitute. So the steps to the working out are UG, we start with the equation, mgh, and we want to make h the subject, so I need to divide by mg. So that gets rid of the GHs on the right hand side, which gives me UG over MGH, and then I can just substitute in the values just like I have over here. 1,323,000 divided by 4,500 times 9.8. When you plug that into your calculator, make sure that all of the denominator is in the denominator. It probably helps to put brackets around it. You'll get the same answer of 30 meters as well. Just a little thing for those who don't like algebra very much. You can actually write this triangle out. So let's say you don't like rearranging at all. You can cover up the h, which is what we want to find, which means that UG is equal to, sorry, H is equal to UG over MG, which is a nice shortcut. Oh, they did not copy out very well. Let's try it again. It's a nice shortcut to not have to do the algebra, but then you just have the solve and substitute again. So how this triangle works is you cover up the h because you want to find out what h is, and then you write out what's left over. So if it's up and down, you write it as a fraction. So you have UG up top, and down the bottom you have MG. And that's quite a nice workaround if you don't like either of the two methods I've shown you. Then from there it's just straight forward as before. Just remember to calculate, convert all the calculations to the right units. Okay, now your questions are these sheets to do, and I will be putting solutions up here shortly. There are these gravitational potential energy questions level 1. I haven't printed that out yet down here, but I will. And then, so these two are what I call separate ideas. So one's a kinetic energy idea, the other one's a gravitational potential energy idea. Then this one is a mixture of both, and the solutions here are using G equals 10. So they might be a little bit off because you're supposed to use 9.8. But if they're roughly the right number, you've done the right thing. And this last question is a mixture again, and the solutions are up here. And some of the solutions are starting here as well, but all the solutions are in here.